this question is related to spanning tree. So let's do a quick review on how spanning tree works. Spanning tree protocol was developed to create a loop-free layer 2 environment, right? So assuming we have a 4 switch environment which are connected to each other via 1 gig link, and the default behavior of all switches are to forward the packet if it does not know what to do with it, or if it does not know where the destination is, it will forward to all the ports except for the one that it received on. So for example, if switch A sends a packet to switch B and switch B does not know what to do with it, switch B will forward to that's the packet to switch D and switch C, and switch C has to do the same thing. It will end up forwarding to switch A and switch D. Now switch D also does the same thing. It will forward to switch A and switch C. Now switch A was sent one packet and it starts receiving 3 packets. It has to do the same thing now again itself. It has to forward those 3 packets, and that results in a like a broadcast storm that will bring the network down. So to avoid such a broadcast storm, spanning tree protocol was developed. Spanning tree protocol uses what we call a bridge ID, which is a combination of a priority and a MAC address to elect a root bridge. Uh, so even though it uses a combination of priority and MAC address to make your process easier, you can just assume it uses two criteria. So first it uses priority, and then second it will compare MAC address. Okay, and still you will get the same result. Now at the beginning of the process, or at when all these switches are brought up online or powered up at one time, all of them is sends out or what you call a BPDU, or messages out advertising themselves as the root bridge. They will say, so switch D will say, hey, I am the root bridge, my priority is 300 and my MAC address is 1D. It will send out that to switch A, switch B and switch C. Okay, now switch C receives that message and says, hey, my priority is 100. The other guy is saying his priority is 300 but is still claiming as root. That is incorrect. So switch A will not do nothing, and it sends out its own packet as well to the switch D. Now so for example, priority from this message, priority 100 and MAC address 1A reaches switch D. Switch D will see the other side has less priority than itself, so it will stop claiming itself to be root and accept switch A as the root. Now what happens in this case, let's see, we have two devices or two switches with same priority. In that case, the MAC address comes into play. Switch A has 1A MAC address and switch B has 1B MAC address. So in case of tiebreaker, the the, the the switch with the lowest MAC address wins. So in this setup, switch A will be the root bridge. And remember, in this election, the lowest wins. Regardless of priority or MAC address, whichever has the lowest value wins the election. So now in this setup, switch A will be the root bridge. Now since it is a root bridge, all its ports are in forwarding state. This all ports will be in forwarding state. Now each switch will start a calculation of cost to the root bridge, and whichever path gives them the lowest cost, that path would be marked as designated, or that part would be in forwarding state, and that port would be called root port. So in this case, since all of the links are in 1 gig connection, this port would be in forwarding state, this port would be in forwarding state, and this port would be in forwarding state. And it also, since this is the from this switch, this is port is the closest to the root or root bridge, this port is called root port. Same thing over here, root port and root port. Now for all the other links, there's other things links, one side will be, and they will do the same election and do the cost analysis, and one side will be designated forwarding, which would be on forwarding state, and the other side will be marked as blocked state. So let's assume these three are the block ports in this setup. So what we end up having is uh, the resulting network is something like this, right? So there will be no loops on the on a resulting network. So now let's go back to this question and see if we can answer answer it. So the the question here is simply to ask or simply to find who would be the root bridge in this setup and why. So the first thing what that all the switches will use is the priority value to calculate the root bridge, and the the switch that has the lowest priority wins the election. In case of two devices, in if two devices have same priority, then only the MAC address comes into play. So the if two devices have same priority, then the device with the lowest MAC address wins the election. So let's see which among these four will be the root bridge. So in this case we have priority 1 for switch C, which seems to be the lowest one. So priority switch C should be the root bridge, and because it has the lowest priority. So the answer is, if I find the correct one, switch C has the lowest priority, so this is the correct answer. And let's review the other answers as well just to make sure. Switch A because it has the lowest MAC address, that is incorrect. Switch A because it has the most centrally located, so location has nothing to do with it. The root bridge election is only based on priority and MAC address. So first the value that is compared is the priority, and if the two devices have the same priority, then only the MAC address is compared, and the device with the lowest MAC address wins. Every other option is incorrect. I hope that explanation was helpful. Thank you for your time.